we have a planet that weighs 5.46 times 10 to the 26 kilograms and has a radius of 7.56 times 10 to the 6 meters. We want to find out what its kinetic energy is, assuming that it has the same period of rotation as the Earth, 24-hour day. So kinetic energy of a rotating body is 1/2 I omega squared. So very similar to 1/2 mv squared for kinetic energy of a linear moving object. So all we need to figure out is I and omega. Now I, for a solid sphere, is 2/5 mr squared. Now we know the mass and we know the radius, so we can calculate I and put it in here. We need to figure out what omega is. Omega is angular velocity. Now this works just like distance divided by time. For normal velocity, this is angular velocity. The distance we travel in radians is 2 pi for one circle, and the time it takes is 24 hours. So our angular velocity is 2 pi divided by 24 in hours. We need to convert this to seconds so that we can get radians per second. So we times by, I want to get rid of hours and convert to minutes on the bottom. So there's 1 hour, 60 minutes. That cancels out the hours. We want to get minutes into seconds. Seconds here, minutes here. So 1 minute is 60 seconds. So omega equals 2 pi over 24 times 60 times 60. So this is our angular velocity of this planet. So now we can plug this omega and this moment of inertia into our kinetic energy formula. 1/2 moment of inertia, 2/5 mass, 5.46 times 10 to the 26th, radius of 7.56 times 10 to the 6th, squared, and that's my moment of inertia, 1/2 I omega squared. So this, 2 pi over 24 times 60 times 60, all squared. Now if we plug this whole schmozzle into our calculator, we get a kinetic energy of 3.3 times 10 to the 31 joules. Final answer.